Question 41, there's a part A and a part B. I'll talk through 41A. We're given 50 mils of a 0.17 molar formic acid, that formula provided in the question, HCHO2, that's called formic acid. Its conjugate base, CHO2, carrying a -1. They're giving us volume and molarity of the acid and the conjugate base. I went to work finding page 667, the list of Kas, and that was reported as 1.8 times 10 to the -4th. The Ka for formic acid I had to look up. It wasn't in the problem. What I did, we have to think about combined volumes. If I have a separate solution, 50 mils of the acid, and I have a separate solution, 75 mils of a base, and I pour them together, I'm actually diluting both of them. So what I need to find is the new resulting molarity. The number of moles in the original solution was found by taking 0.17 molar times the 0.05 liters. Molarity times liters pulled out the number of moles of our acid in letter A. I divided that by the new volume. The new combined volume was 125 milliliters or 0.125 liters. And what I did there was to find the new resulting molarity, HCHO2. That's called formic acid. It's a dilution problem, MV equal MV. The original concentration of 0.17 molar in the 50 mils has been diluted because we have a new combined volume, 125 milliliters. The new resulting molarity, 0.068 molar. I could represent this really, if you wanted to see this as a dilution problem, the original volume, 50 mils, times the original concentration, 0.17 molar, has been diluted to a new combined volume of 125 mils. What's the new resulting molarity? Either way, we're going to get 0.068. Same strategy over here. I took the original concentration, 0.13, multiplied that by 75 millis, although I put that as 0.75 liters. Molarity times liter got me the number of moles. Divided by the new combined volume, 125 milliliters, is 0.125 liters. And now what I have over here is the new resulting concentration of the base. And now it becomes Henderson Hasselbach. pH is the pKa, negative log of the Ka value I looked up, plus the log of the ratio of base over acid. The new concentrations after undergoing a dilution. Solving for pH into 2 decimal places, we'll find 3.8. Again, your numbers may be slightly different depending on what your values are from your homework. Letter B, I'll also talk through the strategy. Let me scoot this up. Letter B was a base. Given 130 mils of a 0.11 molar ammonia with 250 mils of 0.11 molar conjugate acid. This is called ammonium chloride. This is the conjugate acid of this weak base. Since ammonia is a base, it has a Kb value. Again, not provided, so I had to look it up. 1.8 times 10 to the -5th, provided for us in our textbook. A dilution problem. The original molarity, 0.11 molar, in the original volume of 130 mils, what would be the new molarity in a new combined volume, 130 plus 250? That new combined volume is 380 milliliters. You may solve these as MV equal MV dilution problems, or molarity times liter pulls out mole over the new combined volume. We're going to get the same answer either way. And let's verify. 0.11 times 130 divided by the new combined volume of 380, and I get 0.0376. 0.038 is how I rounded that, the new resulting concentration. Same thing occurred over here. The original volume of 250 mils times that original concentration of 0.11. What's the new molarity in the new volume of 380 mils? MV equal MV. the moles per new combined volume, and I found the resulting concentration of the acid. Now Henderson Hasselbach. Remember that it says pH is equal to negative log of pKa. Ammonia is a base. This is a Kb. I had to convert using Kw. Kw, the ion product constant for water, divided by a Kb flips that into a Ka. Negative log that, and we find pKa. Plus the log of the ratio of base over acid. The base is ammonia. Its concentration 0.038. The acid concentration 0.723 molar. Hit that out and you'll find the pH of your solution. Negative log of pKa, we had to flip using the ion product constant. 1e negative 14 divided by the Kb for ammonia. Plus the log of the ratio of the new resulting base over acid solution. Simplify this and you'll have your pH for part B.